A2 Maths, differentiation, chain rule. Right, so what I'd like you to do is just using your year one skills, have a go, expanding that using binomial expansion, and then differentiating it. Okay, so pause it, have a go, replay when you're ready. Okay, so let's see how far you would have got then. So if you're using the binomial expansion and you're talking about year one skills here, because it's not to a negative or fractional power, you should have got two lots, the 2x to the power 4 plus 4 lots of 2x cubed times by the 3. We notice in the pattern it's 6 next because it's 1, 4, 6, 4, 1. 6 lots of that bit squared and that bit squared. Then back to 4, 4 lots of that bit on its own, and then 3 cubed, and then 1 lot of 3 to the power 4. So that's your binomial expansion from year 1, which you know how to do. Let me neaten this up then. Don't forget the brackets so you don't make any silly mistakes like 2x cubed, not 2x all cubed, as it should be. So let's see what you would have got. 16x to the 4, that times that cubed times by 3, 96. 6 times 2 squared times by 3 squared, 216. 4 times 2 times 3 cubed, 216, and then 3 to the power 4, 81. Now the reason why you would do that is because now you're in a position to be able to differentiate. So you could differentiate it by bringing the number to the front, decreasing the power by 1, all what you've learnt in your first year on how to differentiate. So very well done if you managed to get down to that. This is a cubic function, so what you could do now is you can actually factorize it. You could put it back as a factor. So pause there and have a go at just refactorizing it, see what you get. Even giving you a hint as 2x plus 3 is a factor. What you should notice then, if you haven't done it yet, just give yourself a chance to do it. What you should notice is that actually it's 2x plus 3 as the only factor, because you end up with 2x plus 3 cubed, where so there's only one solution to it, one repeated solution. Notice also that the 8 could come to the front. So what you can notice is a bit of pattern spotting between that and what you started with. Okay. Oh look, the power's decreased by 1, same as what it would do normally. Where does the 8 come from? Because you can't just put 4 to the front. We've got an 8, so it's not 4 at the front. So where does the extra 2 lots of 4 come from? Maybe something to do with this 2x just here. In fact, it is to do with that 2x just there. So expect to know a little bit of pattern spotting. Now, obviously, it's not beneficial to keep expanding the function fully and then having to refactorize it. There must be a quicker way to get from a function to its gradient function, and there is, using what we call the chain rule. So in your notebooks, we're going to look at how to differentiate 2x to the power 2x plus 3 to the power 4 without having to do all the expansion parts. So write down that in your notebooks as an example. Title is chain rule, as it says there at the top. All right, let's see what we need to do then. So we've noticed it is a function within another function. So let's just make sure you understand what this means. There's an initial function on the inside, 2x plus 3. So 2x plus 3 is an inside function, like when we did composite functions earlier. So 2x plus 3 is like the first function, and then once you've got that first function sorted, you're then doing another function to it, in this case to the power 4. So it's a function within another function. Okay, usually the hint is there's only a single x value in there. So 2x plus 3 is your function, then to the power 4. It's not always the case, but that's a nice way of looking at usually like a little hint on which one to use. So 2x plus 3 is the first function, power 4 is our second function. And notice we can write it back into the formula to do with composite functions. Our gx function, in this case, would be the 2x plus 3. The f function would be to the power 4. So the f function would take it to the power 4. So it's a function and then another function. Right. So if I let g of x just equal u for the time being, all right, so I'm going to let this equal some value u. Then the equation you get is that y equals fu. Okay. Then what I want to do is I want to differentiate that formula. I want to differentiate that formula. And if I did that, differentiate that formula, then what I end up with is that dy over dx would be the differentiation of dy over du. But then, because I don't want just du, I would have to find du in terms of dx. So there's your inside function, just there. Differentiate u in terms of x. And there's your outside function just there. Differentiate the y function in terms of u. Notice that actually when you look at it, it just makes sort of logical sense. Dy over dx, the du's cancel out, leaving you dy over dx. So you sort of separated it into two equations and just wrote a du on top bottom there. Okay, as long as you can figure out what your u value is, your inside function, then these two bits aren't too bad. Okay, right, so look at an example of that and hopefully make a bit more sense. So if I look at this, I always differentiate the inside function first. So when we use the chain rule, the function of a function, the way you do it is you locate that inside function, you figure out what that inside function is, and you differentiate that first. So in this previous case was 2x plus 3, I differentiate 2x plus 3 first and got just 2. All right, that could be something more complicated, like we looked at with sines, causes, those types of things, or exponential functions. It could be a whole host of different things on that inside function. It doesn't matter what they are, as long as you can differentiate them first. Once you've done that, the next thing you do is you differentiate the outside function. Okay, it doesn't matter, you can completely ignore the x. So the g of x function, you ignore that completely, you deal with the outside function. And again, that could be simple like it was before, which was to the power 4. So you bring the 4 to the front, or it could be something more complicated like sine or cos. It doesn't matter. What is important though, is after you've differentiated it, you rewrite the inside function again. I'll come to that when I come to some examples. Okay, pause there if you need to. Right, so let's have a look. Now you can see this function here is a bit more complicated. Right, I want to find the equation of tangent, so I'll come back to that in a minute. I need to differentiate this when x equals 1. So I'm looking for the equation of tangent when x equals 1. What you want to do is just pause and get it written down. If you want to have a go yourself, by all means do so. What I'm going to do is just have a go at working through this model solution. Okay, so if we're talking about equation of a tangent or equation of a normal, the first thing you need is the gradient function. And that's the new skill. What is the gradient function? Well, if we've got the gradient function, I need to figure out what's the inside function. Now, if I look at this, I've got 2 sine of x to the power 4. It might be easier to think of having, in this case, brackets around there. Okay, if you have brackets around there, you're clearly saying this is the inside function just here. Okay, that's our inside function. And that's where this bit comes from. Okay, so that's our inside function. And then the sine part will be our outside function. That's going to be what I'm going to put as the 2 sine. What I need to be able to do is differentiate both of these parts. So let me differentiate the u part. Okay, so that's going to go to 4x cubed. So I differentiate the inside function first, and then I differentiate the outside function. Now 2 sine u in terms of u is going to equal, sine goes to positive cos. So it goes to 2 cos u. Why does that help me? Well, that u value is just x to the power 4. So I can replace that in there. Neaten it up then. So I get 8x cubed cos x to the 4. Notice your inside function always reappears in your answer. X to the power 4 as the inside function always makes a reappearance in your final answer. Okay, you've also got the front, just the differentiation of that bit, which is why you got an 8x cubed. Right, once I've got a gradient function then, the rest of it is back to year 1 skills. How do you find the equation of tangent? That's going to be y equals mx plus c. or however you want to do it. You might want to do y minus y1 equals gradient lots of x minus x1. It doesn't matter, you choose. So when x equals 1, my gradient function is going to get me 8 cos 1. So I've substituted in my x equals 1 to get my m value. And my y value, when I substitute it back into the original equation, is going to be 2 sine 1. So I get 2 sine 1 just there. Okay, keeping it exact, so I'm not changing the sines and coses. So the equation of the tangent is going to be, I'm using that formula. If you want to use y equals mx plus c, you can do. Be a bit more messy though. So I substitute in my values. So I've got y minus 2 sine 1 equals 8 cos 1 x minus 1, leaving it in exact form. If you don't need to leave it in exact form, if they want you to more work, then yes, get your calculator out, but don't do that. Try to leave it in exact form. There you go, rearrange it slightly. So we've got a certain amount of x, and there's your c value. As I said, not a very neat c value, but you can write it in y equals mx plus c form. Okay, just in case. If they do expect you to write it, remember it's 3 sig figs minimum. Okay, so what I'd like you to do is have a go at these 8 questions. See if you can use just your chain rule on each of those. So you need to figure out what your inside function is, what your outside function is, and then you need to have a go at differentiating them. Okay, so pause there. I'll run through some answers with you in a minute. Okay, so let's see how far you got then. So on that first one, hopefully you notice that this is your inside function. Yes, it doesn't matter, it's square root. So you could write this as x to the 5 over 2, cos of x to the 5 over 2. Right, deal with the x to the 5 over 2 first. Okay, should have got you, if it was x to the 5 over 2, bring that power to the front and getting this part just here, and you would have 5 over 2 at the front of it. Where does the minus 10 come from? Well, that comes from you having the 4 cos u, or 4 cos. What does 4 cos go to? 4 minus 4 sine, which is where that bit comes from. Okay, so it ended up being that answer. Notice that that part there stays in there. Okay, let's look at number 2 then. So the inside function this time is cos 3x. So if you differentiate cos 3x, you're going to get to minus, okay, because it's cos, so it's going to go to minus 3 sine 3x. The outside function is 5 to the power 5. What do you do with the power 5? You bring the 5 to the front, you decrease that power by 1. So it's going to go to 5 lots of cos 3x to the power 4. Put those two together, and that's where you got that bit from. So the 5 and the 3 made the 15 from those two bits. Notice the power's gone down, but the inside function, the cos 3x, reappears just there. Okay, so have a look at this one. I'd say the inside function is a 7e to the 6x. That's my inside function just there. The outside function is a sine. So my inside function, 7e to the 6x, if I differentiate that, 6 times 7 is going to get you the 49, excuse me, it's going to get you 42. So you've got 42e to the 6x. The sine function part just there is going to get you minus a positive cos. I'll get this one right in a minute. Let's start this one again. So the inside function is going to get you 42e to the 6x. Noticing the power doesn't change. So I'm going to definitely have 42e to the 6x. The sine function just goes to positive cos because it's going up. So I'm going to get a final answer of 42e to the 6x cos 7e to the 6x. If you put that in brackets, it's perfectly reasonable, same as it was originally. Okay, right, look at number 4. So number 4, my inside function is up here. So it's sine 4x. When you differentiate sine 4x, that's going to go to positive 4 cos 4x. So I could write that down first. 4 cos 4x. E to the u or e to the whatever differentiates to e to the whatever. It doesn't make any difference. Right? It will differentiate to the same function. So this was going to go to 4e to the sine 4x cos 4x. Okay, or other way around, cos 4 cos 4x e to the sine 4x is exactly the same. Okay, Right, this slightly contradicts what I said earlier on about a single x value, but just be aware that this is your inside function. Okay, it doesn't matter that it's got x squared and x's, that's your inside function just there. Your outside function is your cos. So how do I differentiate the inside function? It's going to go to 10x plus 2. So I can bring out 10x plus 2 to the front. My outside function is 3 cos, whatever, so 3 cos. What does 3 cos go to? It goes to minus 3 sine. Be very aware when you write it, don't put the minus sign in the middle, bring the minus to the very, very front. So your final answer, minus 3. Notice that the 10x plus 2 is here. Yes, you can simplify that, but just be very wary. It's better just to leave it factorised. Cos goes to sine, and this inside function reappears just there. Okay, what about number 6? Inside function's e to the 6x, so that differentiates to 6e to the 6x. Outside function is the power of 5, so that's going to be brought to the front, so it's going to be 5 lots of whatever to the power of 4. Put those two together, gets you 30e to the 30x. Just notice that that's expanded. If you wrote down e to the 5x, e to the 6e to the 6x times by 5e to 6x to the power 4, it's the same answer. Interestingly, this one you didn't need to do chain rule because you could just expand it, and as you can see, e to 6x to the power 5 is e to the 30x. It's the same thing. Okay, so you didn't actually need to use the chain rule at all on that one. Right, number 7, cos to the 4x, then to the sine. Cos to the 4x is your inside function. So what can I do with that? Cos to the 4x goes to minus 4 sine 4x. Sine of whatever goes to cos of whatever. So I should have minus 4 sine 4x cos of cos 4x. Notice in that middle bit there, v appears, but the sign changes to cos. Okay, finally, this one. Inside function is x to the 5 minus 2x to the 3. Differentiate that, it's going to get you 5x to the 4 minus 6x squared. And the outside function is 3e to the whatever, so 3e, and 3e stays as 3e. That doesn't change. 3 comes to the front. E to the inside function is reappearing. There's a differentiation of the inside function. Okay, so very well done if you managed to follow those. There's plenty for you to be having a go at because they involve different skills on there. So you might want to just flick around and have a go at a few of those. Some involve trig, some involve the exponential function, some just involve the polynomials. So it's a good idea to just make sure that you're having a look. Some involve other skills as well, being able to do things like the tangents and normals and those types of things. Okay, and finding gradient functions. So do have a good go at all those questions then before you move on.